Hello, in this video I'll be working through Unit 3 homework problems 44 through 55, and we are continuing to practice the chain rule. Number 44, f of x equals the quantity x plus 5 over x squared plus 2 cubed, and we want to find f prime of x. So this is a composite function. My inside function I'm going to call u. So my inside function is the x plus 5 over x squared plus 2. My outside function, if I replace x plus 5 over x squared plus 2 with a u, then that outside function is just u cubed. So we're going to call this something. I'm going to call it y equals u cubed. I could call it f of u equals u cubed, but I find it a little easier to call it y equals for the outside function. Now we're going to take the derivative of the inside function and the derivative of the outside function. So the derivative of my inside function is du over dx. And that is the derivative of x plus 5 over x squared plus 2. So we need the quotient rule to find that derivative. And quotient rule tells me to take the derivative of the top, so the derivative of x plus 5 is just 1, and multiply that by the bottom, the x squared plus 2, minus the top, so x plus 5, times the derivative of the bottom, and the derivative of x squared plus 2 is 2x, all over bottom squared, so x squared plus 2 squared. Okay, that's the derivative of my inside function. Now the derivative of my outside function is dy du, and the derivative of u cubed with respect to u is 3u squared. So to find dy dx, I'm going to multiply du dx by dy du. So it's going to be 3 times u squared, so 3 times, and my u is equal to this x plus 5 over x squared plus 2. So we're going to replace the u with the x plus 5 over x squared plus 2. So it's 3 times u squared times the derivative of our inside function. So and I'm going to see if I can simplify the numerator there. So it's x squared plus 2, and then I'm distributing the 2x, and I'm distributing the negative 1 at the same time. So 2x times x is 2x squared, times negative 1 is negative 2x squared. And then 2x times 5 is 10x, times negative 1 is minus 10x. And all of that is over the quantity x squared plus 2 squared. So we do have some like terms on the top there. So this is 3 times, now I've got in my numerator x plus 5 squared times, and here I'm going to add these two like terms right here. The x squared and then negative 2x squared is negative x squared minus 10x plus 2. So that's in my numerator. Now in my denominator, I've got an x squared plus 2 squared here. So x squared plus 2 squared, but I also have an x squared plus 2 squared down here. So if I multiply that again by x squared plus 2 squared, that's just going to be x squared plus 2 to the power 4. Okay, and that's about as simplified as we need to go in terms of combining like terms and simplifying. Now I'm going to show you kind of the mental math way to do this same problem if you don't want to go through the steps of writing out what u equals and what y equals and then what each of their derivatives equal. So I'm thinking of this, my function, so the original function y equals x plus 5 over x squared plus 2 cubed. I'm thinking of that as stuff cubed. That's the form that this is in, my outside function, y equals stuff cubed. And I know the derivative of that, so y prime is going to be 3 times stuff squared times the derivative of the stuff. Okay, so that's going to be 3 times stuff squared. So my stuff is x plus 5 over x squared plus 2. So that's squared. Then times, and I'm going to run out of room here, but I'll do my best, the derivative of the stuff. So here we have to go through our quotient rule again. So derivative of the top is 1 times the bottom, so x squared plus 2, minus the top, x plus 5, times the derivative of the bottom, 2x, all over bottom squared, x squared plus 2 squared. Okay, so you can see it's giving us the same result that we got right here. I just did a little more of it in my head and less of it writing out my steps. Number 45, f of x equals the square root of 2x plus 3 over x minus 2. So here my inside function is 2x plus 3 over x minus 2. And my outside function, y equals the square root of u. So we're going to take the derivative of each of these. The derivative of u with respect to x is du dx. And I'm going to use the quotient rule to find this derivative. So derivative of the top is 2 times the bottom minus the top times the derivative of the bottom, which is just 1, over bottom squared. So x minus 2 squared. And if we simplify this on the top, I'm going to distribute the 2. I get 2x minus 4, and then here I'm going to distribute the negative 1, minus 2x minus 3 over x minus 2 squared. And we have some like terms here. So I have 2x minus 2x, that's 0. And then I have minus 4 minus 3, that's negative 7. So negative 7 over x minus 2 squared. That's the derivative of my inside function. The derivative of my outside function is the derivative of y with respect to u, so dy du. The derivative of square root u with respect to the variable u is 1 over 2 times the square root of u. So to get dy dx, which is equal to f prime of x, the derivative that I'm looking for, I multiply the derivative of my outside function by the derivative of my inside function. So the derivative of the outside, 1 over 2 times the square root of u, but we're going to replace u, oh, I need a bigger square root there. We're going to replace u with 2x plus 3 over x minus 2. And I'm multiplying that by the derivative of the inside function, which is negative 7 over x minus 2 squared. And we can simplify that a bit more. So because I have 1 over 2 times the square root of 2x plus 3 over x minus 2, so when you have the square root of a fraction, you can split that up as square root of numerator over square root of denominator. And I have 1 over that, which is going to take the square root of x minus 2 and flip it up to the top. So I have, in my numerator, I've got the negative 7. Then I've got the square root of x minus 2, flips up to the top. In the denominator, I have a 2, and I have a square root of 2x plus 3. And then I also have my x minus 2 squared. Okay, now if we try this kind of the mental math way, more of the shortcut way, I'm thinking of my original equation as y equals, it's in the form y equals square root of stuff. Okay, so my derivative is going to be 1 over 2 times the square root of my stuff times the derivative of my stuff. And in this case, the stuff is the 2x plus 3 over x minus 2. So y prime equals 1 over 2 times the square root of 2x plus 3 over x minus 2 times the derivative of 2x plus 3 over x minus 2. And for that, we need quotient rule. So you can see we're actually doing all of the same steps. I'm just writing it in an abbreviated fashion. So quotient rule, derivative of the top is 2, then times the bottom, minus top times derivative of the bottom over bottom squared. Okay, so either approach is going to lead you to the same answer. Number 46, h of x equals the square root of x squared minus 3x plus 1. So my inside function is the x squared minus 3x plus 1. My outside function, y equals square root of u. I'm going to take the derivative of each of those. So the derivative of my inside function is du dx. That's equal to 2x minus 3. The derivative of my outside function is my dy du, and that's equal to 1 over 2 times the square root of u. So dy dx, which is my derivative that I'm looking for, my h prime of x, is just going to be the product of those two things. So it's going to be 2x minus 3 over 2 times the square root of u, and u is x squared minus 3x plus 1. Okay, and then again, the mental math more kind of way, this is in the form of y equals square root stuff. So I know my derivative is 1 over 2 root stuff times the derivative of the stuff. Okay, so it's 1 over 2 square root of stuff, which is the x squared minus 3x plus 1, times the derivative of the x squared minus 3x plus 1, so times 2x minus 3. And you can see that still gets us to the same answer. Number 47, g of x equals cube root of 9x squared plus 4. We want to find the derivative g prime of x. So my inside function here is 9x squared plus 4. My outside function, y equals cube root of u, which I'm going to write as u to the power 1/3, just to help make it easier to take the derivative. So I take the derivative of my inside function, so du dx, that's going to equal 18x. The derivative of my outside function is dy du, and that's going to equal 1/3 times u to the power negative 2/3. Now dy dx, I multiply du dx times dy du, and I get the 18 times the 1/3 is going to give me 6. And then I have x times u to the power negative 2/3. And u is 9x squared plus 4. Then to the power negative 2/3. If I want to simplify that, I think the only thing I would do here is make it a positive exponent by moving that part down to the denominator. So we'd have 9x squared plus 4 in the denominator, and then that would be to the positive 2/3 power. Okay. The other method, we're thinking of this as the original function as stuff to the power 1/3. So y equals stuff to the power 1/3. Then my derivative is going to be 1/3 times my stuff to the power negative 2/3 times the derivative of the stuff. So it's 1/3 times, the stuff is 9x squared plus 4 to the negative 2/3 times the derivative of the stuff, which is 18x. So we still get the same result. Number 48. So f of x equals x times the square root of 1 minus x squared. We do have a composite function here, but it's also part of a product. So we need to do product rule, and then within our product rule, we're going to end up using the chain rule. So this one starts out as product rule. And the product rule, so my derivative, f prime of x, product rule tells me that I'm going to take the derivative of the first factor. So let's see, our first factor is just the x, and then our second factor is this square root of 1 minus x squared. So the derivative of my first factor is just 1, and I multiply that by the second, 1 minus x squared, plus the first factor times the derivative of the second. And here's where I need chain rule, because I need to find the derivative of square root of 1 minus x squared. So just as a side work over here. I'm going to find the derivative of 1 minus x squared. I want to find that derivative. So my inside function is 1 minus x squared. My outside function, y equals square root of u. My derivatives then, the du dx equals negative 2x, dy du equals 1 over 2 square root u. And when I multiply them together, I get negative 2x over 2 times the square root of u, which is 1 minus x squared. And my 2's cancel out, so I get negative x over square root 1 minus x squared. That's the derivative of the square root of 1 minus x squared. So that's what goes here. Okay, and I can simplify this a little bit. Let's see, we've got square root 1 minus x squared. The x times the negative x is going to be negative x squared over the square root of 1 minus x squared. And now if I want to combine these, I would multiply this first term to get a common denominator. I would multiply it by the square root of 1 minus x squared over the square root of 1 minus x squared. So I'd have 1 minus x squared minus x squared over the square root of 1 minus x squared. And then combining like terms on top, I'd have 1 minus 2x squared over the square root of 1 minus x squared. Number 45, p of x equals x over the square root of x squared plus 1. So we do have an inside function here. X squared plus 1 is an inside function, but it's part of a larger quotient. So we're going to start out doing quotient rule, and then within our quotient rule, we are going to have to do chain rule for taking the derivative of the bottom. So chain rule starts out, find the derivative of the top, which is 1. Multiply it by the bottom, x squared of x squared plus 1, minus the top times the derivative of the bottom. So here's where we need to do chain rule to find the derivative of the bottom. We want the square root of x squared plus 1. Okay, so my inside function, u equals x squared plus 1. My outside function, y equals square root of u. The derivative of my inside function, du dx, equals 2x. The derivative of my outside function, dy du, equals 1 over 2 root u. We multiply du dx times dy dx to get, we multiply du dx times dy du to get dy dx, which is the derivative we're looking for. So 2x over 2 times the square root of x squared plus 1. That's my derivative. The 2's cancel. So we have x over the square root of x squared plus 1. That's the derivative of the square root of x squared plus 1. So that's what goes over here now. Square root x squared plus 1. Okay, so I'm still doing quotient rule. So we did derivative of top times bottom minus top times derivative of bottom all over bottom squared. So the square root of x squared plus 1 squared. Now this is a complex fraction. We've got a fraction inside of a fraction. So to clear that, I'm going to multiply by the LCD. So square root of x squared plus 1 over square root x squared plus 1. Okay, let's simplify this. So on the top, I have to distribute this. When I multiply square root of x squared plus 1 times square root of x squared plus 1, I get x squared plus 1. Then I'm distributing here. So I have negative x times x. That's negative x squared. And then this x squared plus 1 is going to cancel with this x squared plus 1. So I just have minus x squared there. All over. And then when I multiply these two together, I get x squared plus 1. So here it's to the power 1, and over here it's to the power 1/2. So I get that to the power 3/2. So ultimately I just get 1 over x squared plus 1 to the power 3/2. Number 50, g of theta equals 1/4 sine squared 2 theta. We want to find g prime of theta when theta equals pi. So whenever you have a trig function raised to a power, I recommend rewriting it and moving the power to the outside. So the sine squared of 2 theta is the same as the sine of 2 theta all squared, like that. So it's just another way to write our g of theta. And now I'm ready to take the derivative. This is in the form of 1/4 times stuff squared. Okay, so my inside function is sine of 2 theta. My outside function is 1/4 u squared. And I'll go ahead and write down my inside and outside functions. So u equals sine 2 theta is my inside function. Y equals 1/4 u squared is my outside function. So the derivative of my inside function, du d theta, equals, now I have to take the derivative of sine 2 theta, but this requires chain rule. So I have another inside function. 2 theta is my inside function of this inside function. Okay, so this one I'm not going to write out the steps. I'm just going to do this one in my head. I'm thinking of this as the sine of stuff. So the derivative of sine of stuff is cosine of stuff times the derivative of the stuff. Okay, so it's going to be 2 cosine 2 theta. That's the derivative of sine 2 theta. So again, I didn't write out the chain rule steps for taking the derivative of sine 2 theta because I've already, it's a chain rule inside of a chain rule, so I think it's going to get confusing if I write out the steps for that one. Next, we want to take the derivative of our outside function. So that's going to be dy du. Derivative of y with respect to u. So here I'm using power rule. 2 times the 1/4 is 1/2. U to the power 2 minus 1. So when I subtract 1, my new exponent is just a 1. So this is 1/2 u, and u is equal to the sine of 2 theta. So this is 1/2 sine 2 theta. Now, if I multiply du d theta times dy du, the du's cancel out, and I get dy d theta, which is the derivative I want, the derivative with respect to theta. So that's going to be 2 cosine 2 theta multiplied by the 1/2 sine 2 theta. So my 2 times 1/2 is just 1. And then my final answer is going to be cosine 2 theta sine 2 theta. Now we want to find the derivative when theta equals pi. So now we can say g prime of pi equals cosine 2 pi times sine 2 pi. Well, the cosine of 2 pi is 1 times the sine of 2 pi is 0, and 1 times 0 equals 0. So g prime of theta equals 0. Number 51, f of theta equals sine 2 theta cosine 2 theta. We want to find f prime of theta when theta equals pi over 4. So this is going to involve product rule. The first factor in my product is the sine 2 theta, and the second factor is the cosine 2 theta. And when I get to the part where I have to take the derivative of each of those, it's going to involve chain rule. So this is chain rule inside of product rule. So I'm going to start with my product rule. So f prime of theta, my derivative, is the derivative of the first. And I'm not going to write out the chain rule steps this time. I'm going to do this one in my head. This is sine of stuff. I'm taking the derivative of sine stuff. So it's going to be cosine stuff times the derivative of the stuff. Okay, so that in my product rule, all I've done so far is derivative of the first. That gets multiplied by the second plus the first times the derivative of the second. So to take the derivative of cosine 2 theta, I need to think chain rule. This is cosine of stuff. I'm taking the derivative of cosine stuff. The derivative of cosine stuff is negative sine stuff times derivative of the stuff. Okay, now let's do some simplifying here. I have cosine 2 theta times 2 times cosine 2 theta. So that's 2 cosine squared 2 theta plus sine 2 theta times negative 1 times sine 2 theta times 2. So it'll be minus 2 sine squared 2 theta. And then we want to evaluate the derivative at pi over 4. So that's going to be 2 times the cosine of 2 pi over 4. 2 pi over 4 is the same as pi over 2 squared. So I can write my square here in between, or I'm just going to write it on the outside to make it more clear how to simplify this. Minus 2 times the sine of 2 pi over 4, which is pi over 2, squared. So now cosine of pi over 2 is 0, so 2 times 0 squared, minus 2 times the sine of pi over 2 is 1. And 1 squared is 1, so we have 0 minus 2, or just negative 2. F prime of pi over 4 equals negative 2. (52) The graph of the function f of x equals square root of 25 minus x squared is pictured below. Find the values of f of 3 and f prime of 3. So f of 3 we can read right from the graph. This is the graph of f. So f of 3 would be this point right here, is 4. F prime of 3 would be the slope of the tangent line at that point. So we might be able to estimate it based on looking at the graph, but we can do better. Since we have the actual equation, we can compute it. So to find f prime of 3, first I find f prime of x. My equation for f of x is square root of 25 minus x squared. That's square root of stuff. So the derivative is 1 over 2 root stuff times the derivative of the stuff. And the derivative of the stuff is negative 2x. So times negative 2x. So now f prime of 3, I'm just going to substitute in a 3. So negative 2 times 3 is negative 6 over positive 2 times the square root of, and I'm substituting 3 in for x, so 3 squared is 9. 25 minus 9 is 16, and the square root of 16 is 4. Then 4 times 2 is 8. So it's negative 6 over 8, which is negative 3 over 4. So f prime of 3 is negative 3/4. F of 3 is 4. In part B, we're asked to find the equation of the line tangent to the graph of f when x is 3. So we already have all the information we need in order to write the equation of that tangent line. We have our point of tangency, 3, 4. And we have the slope of that tangent line when x is 3, which is negative 3/4. So y minus 4 equals negative 3/4 times x minus 3. Part C, find the equation of the normal line to the graph of f when x equals 3. So this passes through that same point of tangency, so it's still y minus 4 equals something times x minus 3, but the slope is going to be the opposite, so positive, reciprocal, so 4/3. Opposite reciprocal slope for the normal line. (53) At what values of x does the graph of h equals 1/2 x squared times square root of 2x plus 1 have a horizontal tangent? Show your work and give a reason for your answer. Well, a horizontal tangent line has a slope of 0. So we want to know, where does this equation have a slope of 0? So we want to find the derivative and then set it equal to 0. Our derivative, h prime of x, is going to require us to use the product rule. So I'm going to think of 1/2 x squared as the first part of my product, and then square root of 2x plus 1 as the second factor in my product. So I take derivative of the first, the derivative of 1/2 x squared is just x, times the second, so square root 2x plus 1, plus the first, 1/2 x squared, times the derivative of the second. And the derivative of the second, this is in the form of square root of stuff, so derivative will be 1/2 square root stuff times the derivative of the stuff, and the derivative of the stuff is 2. So times 2, and then my 2's cancel. So this is x times square root of 2x plus 1 plus, so I have an x squared in my numerator, and I have 2 times the square root of 2x plus 1 in my denominator. Now I want to know where the tangent line is horizontal, so I'm going to set this derivative equal to 0, because if the slope is 0, I have a horizontal tangent line. And from here to solve, well, we have a couple of options. I can get a common denominator, or I can move one of these terms to the other side. I think I'm going to get a common denominator. We'll do that. So this on the left, I'm going to multiply this one by 2 square root 2x plus 1 over 2 square root 2x plus 1, like so. Okay, so when I multiply x root 2x plus 1 times 2 root 2x plus 1, I get 2x times 2x plus 1, and then plus the x squared from the other fraction, all over my common denominator, which is 2 times the square root of 2x plus 1. And then we're going to distribute this 2x. So 2x times 2x is 4x squared, plus the x squared that's already there is 5x squared. 2x times 1 is 2x. So I have 5x squared plus 2x over 2 times the square root of 2x plus 1. And I want to know when this is equal to 0. Well, a fraction can only equal 0 when the numerator is 0 and the denominator is not. So to figure out where this fraction is equal to 0, all I really need to do is set the numerator equal to 0. And if I set 5x squared plus 2x equal to 0, I can factor out an x, and I'm left with 5x plus 2 equals 0. And then I set each factor equal to 0, I get x equals 0, or x equals negative 2/5. So those are the x values that are going to give me a horizontal tangent. 54, we have a table of values for f prime, g, and g prime. If h of x equals the square root of f times g, is the graph of h increasing or decreasing when x is negative 1? So in order to answer that, we want to know what the derivative is doing when x is negative 1. Is it positive or is it negative or is it 0? So let's find the derivative of h of x. H prime of x is going to be the derivative of the square root of f times g. So we're going to need chain rule for this. The inside function is f times g. So u equals f times g. The outside function is y equals square root of u. So the derivative of the outside function is square root of stuff. So the derivative is going to be 1 over 2 times the square root of the stuff, f of x times g of x, times the derivative of the stuff. So the derivative of f times g requires product rule. That's f prime g plus f g prime. And then when x is negative 1, we want to evaluate h prime of x. So h prime of negative 1 equals f prime of negative 1. So f prime of negative 1 is negative 2 times g of negative 1. G of negative 1 is 1 plus f of negative 1. F of negative 1 is 3 times g prime of negative 1. G prime of negative 1 is 1 over 2 times the square root of f of negative 1, so f of negative 1 is 3, times g of negative 1, and g of negative 1 is 1. Okay, so we have, let's go down here, negative 2 plus 3 over 2 times the square root of 3, or 1 over 2 square root 3. And that is greater than 0. Since the derivative is positive, we know h is increasing. So h of x is increasing at x equals negative 1, since h prime of negative 1 is greater than 0. Part B, p of x equals 2f plus g all to the power 2/3. What is the value of p prime of 0? So first we find p prime of x. We're going to need chain rule for this because it's in the form of stuff raised to the power 2/3. The outside function is u to the power 2/3. The inside function is 2 times f plus g. So the outside function, stuff to the power 2/3, that derivative is going to be 2/3 times the stuff to the power negative 1/3 times the derivative of the stuff. The derivative of the stuff will be 2f prime plus g prime. Now we want to find p prime of 0. So we substitute 0 in for x. So 2/3 times 2 times f of 0. F of 0 is negative 1. Okay, plus g of 0. G of 0 is negative 2. That is raised to the power negative 1/3 times, and then 2 times f prime of 0, which is 2, plus, and then g prime of 0 is negative 3. And let's simplify. So 2/3 times, and in this set of parentheses, we've got 2 times negative 1, which is negative 2, plus another negative 2, so negative 4 to the power negative 1/3, times 4 plus negative 3 is just 1, so we don't really need that. Okay, so this is 2/3 times negative 4 to the negative 1/3. So I have a 2 on the top, I have a 3 on the bottom. The negative 4 to the negative 1/3, I'm going to move to the bottom and make it negative 4 to the 1/3. So negative 4 to the 1/3 is the cube root of negative 4. So this isn't really going to simplify very nicely, but we can say 2 over 3 times the cube root of negative 4. Find the equation of the normal line to the graph of h of x equals tangent of 3x when x equals pi over 12. So we need to find h of pi over 12, and we also need to find h prime of pi over 12. Let's start with h of pi over 12. h of pi over 12 is tangent of 3 pi over 12. 3 pi over 12 is the same as pi over 4, and the tangent of pi over 4 is 1. So we have our point of tangency at pi over 12, comma 1. Now let's find h prime of pi over 12. Before we do that, we have to find h prime of x. So our function h is in the form of tan of stuff. The derivative of tan of stuff is secant squared stuff times the derivative of the stuff, and the derivative of the stuff is just 3. So 3 secant squared 3x. And now I want h prime of pi over 12. So that's 3 times secant squared of 3 pi over 12, and 3 pi over 12 is pi over 4. The secant of pi over 4 is the reciprocal of cosine pi over 4. Cosine of pi over 4 is 1 over root 2. the reciprocal of that is root 2. So the secant of pi over 4 is root 2, and we're going to square that. When you square root 2, you just get 2. So it's 3 times 2, or 6. Okay, so that's the slope of my tangent line is 6. And then the equation of the tangent line, so the equation for my tangent, I'm just going to put a T for tangent. The equation of my tangent line would be y minus 1 equals 6 times x minus pi over 12. The equation of my normal line is going to be y minus 1 equals, I use the opposite reciprocal slope, so negative 1 over 6 times x minus pi over 12.